Hi friends, it's Casey, and we're here today to talk about the best strategies for when you're actually in that technical interview and you've been asked to write code. As it turns out, writing code in an interview is very different from writing code at home on your computer or, say, in a classroom. Just like taking a standardized test, say writing an essay for a standardized test, there's kind of a different format that you may be expected to write as opposed to if you were just doing it creatively. And in this video, I'm going to walk through all of those parts and specifically highlight what I think are the hidden or unsaid expectations, especially because you'll find a lot of people who have a large community already in tech, they talk about these hidden expectations all the time. And it's really important for those of you that maybe don't have that type of network to still show up with the same level of context, because unfortunately, people are not going to offer that to you. So let's talk about some of the things that make coding in an interview a little different from coding just by yourself at home or in other ways that you're more comfortable. So first of all, when the interviewer presents you the question, many interviewers will intentionally present a question with not enough information for you to actually get started coding. The logic behind this is that they want to see how you ask clarifying questions, how you define ambiguity, how you avoid making assumptions, and it is a good and important part of your thought process to go through and make sure you understand everything you need to know before you dive in and just start coding. But they're not going to tell you that there's not enough information in the question, and a lot of students just dive right into coding because, you're a little nervous and your brain's working fast. But you need to know that there is actually an explicit portion of the interview where they're going to expect you to ask follow-up questions. Now, some interviewers may try to avoid this and they will present you with a question that they think is fully complete, but you still want to make sure that you ask clarifying questions to give your brain time to really digest everything and be sure you're answering the right question. Again, stress brains just do weird things under interview circumstances, and it's actually really easy to slightly misinterpret the question and just code the totally wrong thing. Maybe you end up using the wrong return value or you go after the wrong strategy, something like that. So at the very beginning of the coding portion, there's actually going to be a lot of dialogue between you and the interviewer where you ask a bunch of clarifying questions and they sort of help make sure you come to the correct understanding of the question prompt. Also part of that discussion is what we might refer to as the outlining your plan portion of the interview, where after you fully understand the question, your interviewer is going to expect you to tell them, okay, how are you going to approach solving this problem? And that should actually be a bit of a conversation because in that section, the interviewer is going to hopefully help you a little bit, maybe provide some hints or give you some indication as to whether or not the thing you're proposing is a valid solution. And you're going to need to have that conversation and get some kind of almost approval or go ahead from the interviewer before you actually start writing code. So these two things need to happen before you write any code down after the question prompt is given to you. Then, throughout the whole process, but especially while you're actively writing your code, you need to be narrating your thought process. This means talking aloud, even if you're trying to decide between two things. Again, it can feel very uncomfortable to do this in front of a professional engineer. You don't want to say something, quote, stupid or naive, but I promise you, it's actually the best way is to start from a simple approach and then refine it to demonstrate to them the overall process of how you go from, I'm not sure how to do this, to I've figured out a plan. That journey is more important for them to understand than the final destination. In fact, lots of interviewers like myself will pass candidates who don't even complete the question if we feel we've gotten a very clear picture of what you are attempting to do and how you got to that solution. Because we know coding under a timeline can be a little weird. We care more about the thought process than your code. But if all you've ever done is write code for school, chances are you're not used to talking while doing it. So that's a very different dynamic you're going to want to practice. And the other thing to keep in mind is that for a lot of companies, and it does vary, completeness is more important than optimality. Meaning, once you're presented with the question, it's likely that you may more quickly come up with what would be referred to as the brute force approach. And I know when I was doing my interviews, I would come up with a brute force approach, but then I wouldn't want to say it aloud or get started on it because I wouldn't want the engineer to think that I wasn't a good coder. I didn't know how to come up with the most optimal solution. But that kind of puts a hiccup in the way that you're thinking and stalls your momentum. And that has been one of the major contributing factors I've seen to students not finishing the coding problem. You're going to want to prioritize actually getting a working solution over finding the most optimal solution, because as we get deeper into the video, I'll give you some strategies, but you can actually get full credit for an optimal solution you don't code. You just talk to after you've coded the brute force solution. And then finally, it depends on the length of the interview, but likely in the sort of second round hour-long interviews where you're going to spend 45 minutes or so doing the coding portion with your interviewer, they've likely prepared multiple questions. This is because everybody codes at different rates and everybody has different levels. And so they tend to start off with something that they would expect a larger percentage of candidates to pass or to understand so that you have something to kind of get started with. And often it will be expected that you do complete that first problem and then you make, say, significant progress into the second problem. Some interviewers may expect you to kind of finish that second problem, and there is likely to even be a third problem after that for those of you that are super speedy, just so that they make sure you're not just ending the interview early or sitting in silence. This is a really common technique to pick 3 questions, but it does vary by company and vary by interviewer. And students very regularly ask me, how many questions do I have to complete to pass? And you should know it does totally vary, but if it's going to be a series like that, I usually say you should expect to get at least through the first one and make what I would call significant progress on the second one, i.e. you have a good amount of code down, even if it doesn't fully compile or solve the problem. That's a lot of things to remember about the interview. And one of the reasons I even got into this work to try and help students pass interviews is because I was constantly experiencing this where I would talk to a student, I could tell they were really smart, I could tell they were really enthusiastic and they had great experience, and then I would present them with the coding problem and I could see their brain just sort of freeze. Or they would spend too much time in the discussion portion, or they would spend too much time in the testing portion. And so we realized it's really hard to structure that 45 minutes of time when you're really stressed out to make sure that you hit all of these items. So we here at Kim and Casey's channel has come up with a memory device for you to use in the interview to make sure that you're breaking up that 45 minutes and addressing each of the things you need to do within the interview. So, in any technical interview, make sure you remember codes. Clarify the question, outline your plan, develop your solution, evaluate your code, and suggest optimization. Codes, get it? And so really what this means is the C stands for clarify. That's about asking those follow-up questions, making sure you really understand what you're being expected to code before you do it. O stands for outline, i.e. that kind of conversation you're having back and forth with your interviewer to make sure that you are headed in the right direction, that they understand where you're going. D stands for develop. It's time to actually write your code down. But you see, that's actually step 3, and that generally comes maybe after about 10 minutes of the coding portion. And then after you've written your code, you're not done. E stands for evaluate, which means go back and test your code. It's really easy to miss a pretty obvious bug under these stressful circumstances, so you want to make sure that you actively plan for a step to just double check and test your code. And then finally, S, suggest optimizations. This sort of depends on the scenario you're in. But again, if you're driving for completion or you're trying to just talk about your problem solving strategies, then you might, as you go through the code, realize, oh, I wish I had done that, or this would be more optimal. You don't want to interrupt your original code. That might waste time, or you might not get to completion. So you kind of want to save those ideas and then at the very end, run through what you would have done differently. So make sure in your interviews you're always remembering this device and then take those 5 steps, and you should definitely make sure you're going to hit each of those requirements. Now, I'm going to go through each of these 5 steps in more detail so you understand exactly what's going to be expected of you from the interviewer in those scenarios. So, step 1 is clarification. Like I said, a lot of engineers really believe in this idea that they should intentionally give you essentially a bad question. Not so much in that it's a bad thing to ask you to do, but it's an incomplete amount of information for you to accomplish your task, which is very different from school, where we as instructors spend so much time making sure that your homework assignments have every single thing in there to answer all of your questions for you to work on it. The point of this step is for you to demonstrate your critical analysis, your problem solving, your communication, and to showcase that you do not make assumptions when coding. One of the worst things you can do in an interview is just hear the question, make a bunch of assumptions, and then start coding to a slightly different version of the problem. It happens all the time. Stress is a weird thing. So make sure you take an intentional amount of time to stop and ask the interviewer questions. They will be expecting you to do this. So here are some examples of good questions to ask. Things you want to clarify are, what type of input is coming in? What is the form of the return you want me to make? Is there guaranteed to be a solution? Is there only going to be one solution? What are the different behaviors if, the input is null or the input is empty? Or can I assume good user behavior? Maybe even more specifically, you want to ask about with strings, like, does capitalization matter? Maybe you want to ask about data types. But really, you want to make sure that you're stopping to understand everything you need to be sure you're writing the right code. And in fact, one of the best ways to be sure that you're writing the right code is to actually run through a set of inputs and outputs. You might think of these as unit test cases. One of the best ways to ensure that you fully understood what your interviewer is asking of you is to translate your understanding from your clarifying questions into a series of inputs and expected outputs that you ask the interviewer to confirm. And if you really want to be fancy, the best way to think about what types of inputs and outputs you want to clarify is to go through a basic set of test cases, sort of like a unit test suite. You're not actually going to write the unit tests, but it might help guide your thinking into what types of inputs and outputs you're going to want to confirm. And then at the very end, when it's time to test your code, you've already thought through the test suite, so you can just go back and reference it. So when you're starting to approach the series of inputs and expected outputs, I suggest you start with what we might refer to as the functional cases, just sort of the average and practice case, like what happens if the user's behaving totally in good faith and the solution is the one that's most likely to be found, things like that. Once you've confirmed that sort of foundation, then maybe you want to start to think about boundary cases, like is there going to be some different behavior if you run off the end of your input, or if the thing you're looking for is at the front of the input or the back of the input, or anything in that sort of nature to make sure you fully understand how the orientation of your input is going to react and then what the overall outcome might be. And then finally, you want to go through and sort of confirm what we might refer to as valid behavior. This is, what happens if the user gives me something that is a little bit of a departure? Like, what happens if the input is empty? What happens if the input is null? What happens if the input contains a slightly different style of input, say a negative value? Or what's the difference if there's capital letters or lowercase letters or zeros or empty spots in the array? Anything that might happen that could sort of break apart the logic of the in practice case, you're going to want to confirm here so that you fully understand what level of complexity of input you are going to need to address. One of the questions I get asked most often by my students is, what happens if I get a question and I have no idea how to respond to it? A really understandable fear. I think this type of situation falls into 2 categories. One being, it's really stressful to be in an interview and you get asked something that maybe is a little on the hard side, but you probably could piece together, but your brain just sort of freezes up, and in the moment, you just can't think of what to do. We're going to talk throughout the rest of this video about strategies of how you kind of unstick your brain and move forward, but the other type of problem is when they ask you to do something you just straight up have never heard of. Like maybe they ask you to use a particular type of feature, or they ask you to use a particular type of design and you just haven't taken that class in school yet, or you've never been exposed to it before. Happens all the time. There's so many different topics. It is possible you could get a question that you just don't know. And that's okay. The best way to handle this, in our opinion, is to just address it. Tell your interviewer right away. But you want to play this very optimistic, always ready to learn sort of personality that will make sure that it doesn't make this uncomfortable. You don't want to just say, oh, I don't know how to do that, and push the question away. You still want to lean into what they're asking you to do. So we suggest saying something along the lines of like, oh no, I haven't had the opportunity to study that yet, but if you're willing to help do a little coaching or instruction, I would really love to try. Now, some interviewers may take you up on this, and then maybe you have a really positive interaction where you sort of pair and they teach you something. That could tell an interviewer a lot about your intellectual horsepower, your ability to solve problems and learn new things, and your ability to communicate. But more often than not, the interviewer will be like, oh, I'm not prepared for that kind of interview. That's really nice of you to offer, but I'm just going to change my question. I have asked interviewers to change the question in the interview this way, and they absolutely did so. And I have done this for students when I've conducted an interview. It's very par for the course. You don't have to feel awkward about saying this. Just always give them the option that you're still willing to work on it if they are also willing to coach you. Now it's time for step 2. It's time to outline your plan for what code you're actually going to write. And this, very importantly, actually needs to be a bit of a dialogue between you and the interviewer. The reason for that is that the interviewer comes prepared, likely with the set of known solutions for that question. It is very unlikely you're going to invent a new solution to this question. Most interview questions really only have a few different answers. And during this time period, this is probably when your interviewer is paying the most attention, because they're very quickly trying to figure out like, oh, which of those solutions are they going to go after? And part of the reason for that is that they likely know some of those solutions, like they might know which ones are dead ends. They might know which ones are more likely to be efficient. And that could be some of the most impact on your score. Now, a lot of interviewers during this time period will somewhat intentionally start to kind of drop hints about which direction you should go. But it's also deeply important that you have this sort of dialogue and back and forth so they can really understand how you're thinking about approaching the problem. And you do not have to worry to tell them things that you then eventually decide, oh no, I'm not going to go that direction. They want to see your thought process. In this time period, you want to make sure that you're not just going silent and then trying to come up with the ideal solution and then just telling them that. Again, it's really about that back and forth, that communication. Maybe you also are sort of narrating aloud any of the design trade-offs that you're considering, like, oh, this one might have better runtime, but maybe if I go this way, I'll use less memory. Maybe you also want to call out any assumptions that you need to make in implementing of those things so that the interviewer can start to clarify beyond what your original set of questions are. So it's really important that you're very actively engaging with the interviewer. And in fact, like I said, the interviewer might try to actually give you a little bit of a lead during this time. It does vary by interviewer. Some people really feel that they should not get involved at all, but especially for university students, you'll find a lot of interviewers are rooting for you. They want you to pass the interview. It makes their job easier. It's easier to write interview results for somebody that does really well. And so during this time period especially, pay very close attention to if the interviewer is particularly interested or excited by one of your solutions, or they're trying to offer you little things. This is the moment to take all of those hints and really follow their lead, because they're trying to figure out, like I said, which of the solution categories you're falling into. You should also know that the solutions might be sort of tagged in terms of what they're expecting from you as a level of optimality. So behind the scenes, for example, and a lot of the companies that I conducted interviews for, we might have 3 different levels of solutions we are aware of, where there's, say, a brute force solution. Maybe it's just a nested loop. You loop over everything, or it's recursive backtracking. That will find you a solution, but it's not super optimal. that we might refer to as, quote, the naive solution. Now, if that's the only solution you've got, great, you still have solved the problem. It might also be the first solution that comes to your mind. That's also okay. Say that aloud. You want to show them which solution comes to your mind first, but if that sort of brute force is the thing that first comes to your mind, give yourself a little bit more time, maybe a few more minutes to kind of discuss with your interviewer to see if you can take it to a slightly more optimal place. For example, if you can take it from an n squared to an n log n, that's a huge improvement. That's usually the transition between what we would call a naive solution and an acceptable solution. Sometimes, of course, it depends on the context of the question. There might be an even third level, like a most optimal level, and maybe there's some cute trick thing that you need to do. Like there's a bit shift or a little math trick, or maybe something about using sort of hash tables on hash tables will get you from even an n log n to a linear or even a constant time runtime. And that, of course, would be the ideal to push in that direction. And so that's why your interviewer might be particularly interested in paying close attention during this time, because they're trying to help guide you into one of those categories. This also might be a moment where interviewers know there's some sort of like dead ends out there, and they might try to help you avoid those. So take a lot of the advice here, make sure that you come up with something, and then do not start coding until you have what is essentially a go-ahead or an approval from your interviewer. They're not going to tell you, yes, that is definitely going to work, you should get started. But they might say something like, okay, let's see how you do that. Or yeah, let's get started. Or oh, let's translate that into code, which is essentially them saying it's time for you to get started on the coding piece. What they're really looking for in order to be able to say, yeah, it's time for you to get started is sort of like a high level, maybe it's around 2-sentence description of what you're trying to do. Here's some examples of the level of detail you're trying to get to before you officially start coding. You know, like we can loop over the array, and for each index, we can sum up the integers before it and, you know, update the index in the corresponding array. And they will probably not ask you for the big O in that moment, but it's good to keep in your mind like, oh, like I can tell that's a linear solution. That's probably going to be well within the acceptable category. It's a really good way to get started. Another one, you might want to call out, for example, the algorithms you're using, the data structures you're using, the overall technique. So you could say, hey, we're using recursive backtracking to generate all possible things. And then we want to look at all the possibilities and sort and find the minimum value. This is sort of the level of detail you're looking to get to so that the interviewer has enough context to realize, oh, they're going after the second type of solution, and then you can get started on actually coding. All right, step 3, it's finally time to start writing code. So you can, of course, write code in whatever way makes your life easiest, but I'm going to go through a few suggestions on how I think you might help your brain get unstuck or to follow a pattern that will be easier for your interviewer to follow along with. And so the first thing you want to do is at least write that function header. Make sure that you know the name. Make sure you know the exact style of input. Make sure you really understand what the different parameters are so that you really are sure you're coding to the expected interface of the solution. Once you've got your header, now some people just write code sort of from start to finish. But if your brain's getting a little stuck in that sort of linear thinking pattern, another thing that can kind of help unstick you is you don't have to necessarily solve the whole problem and then start at step 1 and go all the way to the final step. Chances are you can start to think like, oh, what pieces are going to exist in here? What control structures do I know am I going to need? I know I'm going to need some type of loop that goes over my input. I'm going to need some type of if statement that compares this versus that. Think about like those sort of key pieces, especially too, like starting with the average case or sort of the most likely the in practice case. That tends to be the one that our brains find more easy to digest. And then once you get through that, you can start to do those boundary cases. The other thing you're going to want to do is please make sure you are narrating your thought process throughout this entire period. Now, this can be really uncomfortable for people, and I have been in lots of interviews where people get a little stuck and they go quiet for a time, and I know during this period, any amount of silence can feel like a lifetime. But I would do your best to make sure that you're not going totally quiet for longer than a couple minutes. Even if you're stuck on something, just say, oh, you know what? Like, I was heading down this path and I got a little stuck. I'm trying to figure out if I go this way or that, or, oh, I'm trying to think of what the right data structure is. Not only does it help them understand your thought process, but if you help them understand where you are stuck, they might try to offer some suggestions for how to unstick you. If you just go silent and then write all your code while your interviewer is just sitting there, one, your interviewer is probably going to check out, which is not a good idea. You want them to be engaged and following along with you. And then two, you might be headed in a totally wrong direction and your interviewer would never even have the ability to sort of jump in and support you. This is a really unique skill, so you're definitely going to want to practice this at home, no matter how silly you feel, just doing your leak code or HackerRank problems, talking as you do them. Some things to think about as far as the type of code or the quality of code that you actually leave behind. Do keep in mind that the code is probably going to exist in that room and with that interviewer longer than you are. Like maybe it's on the whiteboard and after you leave the room, the interviewer is going to look at it and then write their notes. Or maybe it's in a doc that will get attached to your interview packet. Now, nobody's expecting you to write the world's fanciest, cleanest code, especially under duress and in a time period, but you do want to make sure that you're leaving code behind that speaks well for itself. So for example, do use good variable names. I cannot tell you how annoying it is when a student comes in and they think just because it's an interview, they can just name all of their variables like A, B, C, D, E or something. One, it's confusing for me to read. Two, it's going to confuse you at some point. And three, that's not the type of code I'm going to want to welcome into my code base later on. So you're going to want to try and represent within that construct the best you can, the type of code you would actually write in a professional setting. Same thing with like white space conventions. Yeah, it's okay if like, oh, I thought of this later. I'm going to like draw it over on this side of the whiteboard and kind of draw an arrow in, or maybe I'm sort of adding pieces here and there, but it almost makes my eyes want to bleed if you don't at least use basic white space conventions. And most professional engineers feel this way. So at the very least, try to make sure that you're not writing code that would like offend their sensibility. One thing you don't have to worry about that you may have to worry about a lot more in school is writing really maintainable or module code, or for example, eliminating all of the redundancy. And a lot of our coursework, you can get graded on any level of redundancy. It's a really convenient and easy point to communicate to students. And we do care a lot about redundancy in product code, but in an interview, it's okay if you need to repeat an if statement or, hey, like you're writing something and then you realized, oh, I want to reuse this piece of code for later. You can kind of draw a little box around it, maybe be like, hey, I would turn this into a private method. I'd call it this. And then you can kind of sort of use that afterwards. But don't worry so much about writing the type of code that is intended to live in a code base for years on end. Now that you've written code that should complete the problem to the best of your understanding, I know it's very tempting to just want to be done with it, rush out of that room. I've actually had students start to stand up because they're just so ready to be done with the interview. But keep in mind, you still need to confirm that your code actually does what you think it does. And it's time for step 4, E for evaluate. The first and most important part of this step is to just straight up check, did you forget anything? Brains under stress do funny things, and I cannot tell you how many times I've seen students forget to just include the return statement, or they forgot to update the current pointer on their linked list. Those come up all the time, so make sure you take a moment, take a breath, and just look over your code to be sure it's done. Then you also want to check that your code actually does everything you've asked it to do in terms of the test cases you outlined in step C. This way, you've already kind of set up your test suite and you know your interviewer agreed those are the things you need to do, so you should treat those as your sort of requirements that you need to meet. You also might find in this moment that you want to add more test cases to be sure of what you've actually accomplished. Now, when I say add test cases, you don't actually have to write test code. you really just kind of want to look at the input-output examples and kind of talk through your code to say, oh, like if I put this in, this is what would happen, and then confirmed, yes, that is the expected output. So do that for all of the steps that you did for all the input and output you did from the first step. But then you might also want to add a couple things to be sure that your code's going to behave correctly around the boundaries of your, say, control structures. So one thing you might want to do is think of a case where you do enter the if statement, or a case where you do enter the else if statement, or then finally, what happens if you enter the else statement? Be sure you can cover each of those branches. Also, when approaching loops, make sure that you think of a test case where you never enter the loop, or you enter the loop and you are sure you exit it, or what happens, if you run into a possible infinite loop. All of those types of things will demonstrate to the interviewer not only that you have enough understanding of your code to go back and be self-aware about it, really good code review skills, if you will, but also that you have the ability to fully develop a test suite. Pretty much all professional developers today are going to be responsible for the quality and the functionality of any code they submit to the code base. And so this is equally as important a skill to be able to generate a fully comprehensive test suite as writing the code in the first place. But if this stresses you out, don't worry too much. We know this is something that is a little harder to learn while in school, especially as professional engineers. We just see a lot more patterns of what can go wrong. We just want to see that you understand this is an important step and you can cover the basics. And then finally, and this is a bit of an optional step, we have S for suggest. At the very beginning, I mentioned we really care a lot more about completion than optimality. Well, this is the moment to sort of like grab any of those extra points or, good brownie points just by talking through anything you would have done differently about your code. This way, as you've been talking through things and then writing your code, chances are you may have thought of something you would change or something you're like, ooh, like I'm kind of working through this linear problem, but I can imagine that if I did it this way, it would be constant. You don't really want to stop and interrupt yourself mid-code to switch your design in total. I have seen students do this, and a lot of times it's just a waste of their time, and then they never end up with a fully complete solution. You do not want to do that. So if as you're going through, you notice little things, maybe just kind of jot them down or call them out to the interviewer that you're like, oh, I could see how maybe a hash table would have been more optimal, but I'll talk more about that later. This is the time to talk about it. And the really cool thing about that is that if you write code that maybe is even in the naive or acceptable solution categories, and then at the very end, you have it all complete, it does solve the problem, and you just tell me, you know what, next time I would have used dynamic programming to optimize this into that runtime or into this runtime instead of that, I actually give you full credit for having coded that solution, because I think of those as two separate skills. One, being able to translate your ideas into code that fully works, and two, finding ways to optimize code. So you could write a brute force solution and then just explain the optimal solution to me at the end, and I'm going to give you full credit for having written a working optimal solution. This also is a great time to sort of demonstrate your self-awareness and your code review skills, because also another incredibly important part of our job isn't just to write code and then throw it into the universe and never look at it again. We have to live with all of the code we write for sort of forever and always, and also our colleagues need to as well. So your ability to stop, review code, and think about ways to make it better is also just as important a skill as, say, testing or writing the code in the first place. Now that we've talked through all these steps, let's dive into an example so you can see them in action. Let's say it's time for your technical interview and you have a 30-minute technical screen, and your interviewer at the start of the coding portion says to you, given a string, find the duplicate. This is actually a pretty common style of interview question. It's a pretty traditional one. Hopefully you right away are like, wow, that's just not a lot of information. That's barely a sentence. Very common for especially those types of internship or technical screen questions. So right away, we know we want to start with C for clarify, and here are some example clarifying questions you might want to follow up with. Especially when it comes to strings, you want to make sure that you understand what the differentiation in characters might be. You also want to understand, does a solution exist? Is there guaranteed to be a duplicate? Is there only going to be one solution or one duplicate? What is the return value? What happens if there is no solution? And in this case, you can see what they've sort of told you is, yes, there's going to be a duplicate. There's only, like, if there is more than one, you want to return the first one. And then in the case of no duplicates, here we have that sort of like null character value that's specific to Java. Look up for your language what you want to return. You will also maybe notice that as you ask these questions, the interviewer may already have a sort of set amount of answers, meaning they're expecting you to ask these questions. They also might kind of on the fly be like, yeah, let's say you can accept more than one duplicate, but you just return the first. And often if they're sort of inventing it on the fly there, chances are they're going to adapt it to try and make the question as direct and simple as possible, mostly because that makes their review really elegant. So honestly, the more questions you ask, the more you clarify, the simpler a problem you might end up with as you've clarified even beyond what the interviewer was originally anticipating. Then it's time to come up with your set of input-output examples. Now, like I said, you kind of want to start with that maybe average case. Like, can we just detect a duplicate if that's all there is in the string? Just two A's? Well, then we want to return A. Then maybe another sort of average case, but here you can see we're exercising whether or not there's multiple duplicates. And so AA, BB, CC, we know we want to return the first duplicate, which happens to be A. Then for our third case, you can see we're sort of exploring that capitalization thing. So we know for this, we want to return that null character. And then we've got a few other ones here that sort of explore those other boundaries. You don't have to write a totally complete test suite here, but you do want to come up with, like, let's say at least 2 to 3 of these input-output examples to show you've really understood things, maybe as many as 6, so that you can use that test suite and that final E stage when you get to it. Now that you've fully understood the question, it's time to get to that O for outline phase. Again, you're going to have that back and forth, but what's on the slide here I'm going to show you is actually the type of things that would be in my notes as the interviewer, that kind of 2-sentence level, this is the general approach they're going to go for, and then also sort of organized by the runtime in Big O and the memory usage. So for this find duplicates problem, the initial idea of how to solve it, the most brute force method of how to solve it might come to your mind first, and that would be creating a nested set of for loops where you start at index 0 and then you loop over everything else in the string and you compare it. If you find a duplicate, you return, great. If not, you continue on to index 1 and then you loop again and you loop again and you sort of get that n squared runtime, but nicely, it doesn't use any extra storage. Moving up a category in optimality. So maybe that first category is what we would call the naive solution, and maybe this middle one is more of the acceptable solution. That's to leverage some known algorithms, and this is actually a really common technique. If you're ever looking for duplicates or you're ever looking for something in a collection and it's something that's very easy to sort, well, if you sort a string, well, you know that duplicates are going to be right next to each other. Keep in mind in Java that strings are immutable, so you can't just sort the string. What you would do is you would linearly move over the string, transform it into an array of characters, and then you use the arrays.sort functionality to sort that arrays of characters, which will execute an n log n runtime. And then you just, again, go over that final sorted collection in linear time, and you just look for any 2 items right next to each other that are the same. This way, instead of doing it in n squared, you are moving in that n log n runtime, but you are adding that array of characters, so now you have n extra storage. But can we push it even further? When in doubt, always consider if a hash map is going to make your code more optimal, especially when you're comparing items within a collection, because hash maps have constant time lookup and constant time put. So if we create a hash map and we start to move over the string letter by letter, For each letter, we ask, hey, is it already contained in our hash map? If the answer is no, put it in the hash map, both of which are constant time functions, and then just keep looping. And the first time you find that something already exists in the hash map, well, there's your duplicate. So now you've got a linear runtime, and you do use that linear and extra storage, but that's what we would maybe refer to as the optimal solution in this case. Once you figured out where you're going for, then it's actually time to write your code. Here's my coded solution for the optimal situation for this one. So you can see I have my method header, I have a return type of char, I have an input type of string. I start a result variable, and I set it to that default I didn't find anything. And then you can see I check, hey, is there anything even in the string to look at? This is going to protect me from any unnecessary things and also protect me from any unnecessary calculations or any possible exceptions. I make a new hash map. I loop over the string from the very start to the very end. And then you can see inside the for loop, I'm just checking, hey, does my hash map already contain that particular character? If it does, then return that character. That's my duplicate. Otherwise, put it into the hash map. And then if I get all the way down past that, meaning I never hit that return inside of the for loop, it means I've looped all the way over the string. I never found a duplicate, and I can just return result whose default value is that null character, i.e. I didn't find anything. Now that we've gone through that, it's time to kind of go through and evaluate or check your test cases. And the way you're going to want to do this is you have your input output examples, and then you look at the code that you've written. And like I said, you just kind of talk it aloud. So let's say input equals AA. I set result to that sort of empty character. The input.length is definitely greater than 0. So I enter that if statement. I make my new hash map. My for loop is going to loop initially. It's going to see that first A at index 0. It's going to notice it does not contain, so it's going to hit that else statement. It's going to put that A into the map. I'm going to come back around and loop, and then I am going to go through, and by the second A, I should hit that if statement. If dupes.contains key, that input.char at I, which would in that case will be 1, it'll hit the dupe that we already put in there from index 0. It'll return that particular character, and then I'm done. That might be a little bit more detailed than you want to go into for each of these, but you can see I kind of talked through line by line and what the eventual result will be based on that particular test case. And that way, sort of talk through those at a high level. This particular stage of the coding interview, it depends a lot on how much time you have left in your interview, but try to keep that to a couple minutes, and you will see if your interviewer, asks you to go in more detail or not. And then finally, let's say you originally came up with that brute force solution, the n squared one. Again, totally fine. This is the time where, oh my gosh, okay, as I was doing it, I realized it would be really great if I could just sort that, and then I'll just go linearly over it. Like, oh, actually, you know what? A better solution would have been if I went through and I created the hash map, and then I used whether or not the hash map contained the item already to see if there was a dupe. If you had followed up the n squared solution with any of those types of descriptions, I would have given you full credit for the acceptable or more optimal solution. So there you have it. That's just a way to sort of structure your thoughts within that very terrifying time period after the interviewer has given their initial question. And again, remember, it's actually more important that you kind of go through each of these steps than it is to just race in silent coding to the most optimal solution. Make sure you're always taking your interviewer along on the journey. Do your best to sort of follow their lead, especially in the design phase. And by doing all of these things, I'm sure you're going to leave behind code that's going to really well represent the ability that you have to write code that excites your future coworkers. So good luck studying. Make sure that you do lots of practice. Always talk through your solutions. And if you ever need any help, you can always come back to this channel for lots of examples and more advice. Don't worry, Kim and Casey always got your back.